Lights, camera, action. Okay. Okay. So number one is write these formulas. They used to be on the board right here. You guys remember them?
Nope.
Simple exponential growth formula. I'll call that 1A. And then B is compound interest. So those need to be memorized. They're going to be used on other problems on the test. All right, what was the simple exponential growth formula?
A times 1 plus r to the t.
A times 1 plus r to the t. Or you might put, I don't really care about this part, but you could put f of t equals that. And then what was, so compound interest was very similar.
It has the r over k and then t times t.
Yeah, r is over k, and there's a k on the t also. So f of t equals a times 1 r over k t. I don't know, you guys think you remember that? No. Well, that's one of those things I'll grade at the beginning, then if you get it wrong, I'll correct it for you. It's still wrong, but you can still use it on the other parts of the test that need it. Alright, are we good for number one?
Yep. Yeah.
What's different between A and B and C and D?
That's the little circle thing which means it's the function of.
Well, on A and B,
It has a
you're plugging in the numbers, so you're going to get a number answer. On, you don't really have to add these two functions together. You just figure out what g of -1 and f of -1 is and add those together. But on C and D, it says x over here. So you're not plugging any numbers in. All you're going to do is simplify f times g, those two functions. Or what does the circle mean? F of g of x means
you plug in what g is for the x.
Yeah.
F
you put the g function into the f function. So on B, you figure out what g of -1 is and put that into the f function. Figure out what f of that is.
Justice, you're gonna check out.
Justice, I'm recording this if you want to watch.
It's cold.
Alright. Number 2A. So, what is g of -1? 5 times -1 plus 1 is -4. So really what we need to figure out on this one is what is f of -4? G of -1 is -4. Whoops. Forgot what I was doing, my bad, that's wrong.
We did number B.
G of, we still need that though. G of -1 is -4. F of -1, -1 squared is +1, girls, times 2 is 2, plus 3, 5. 5 minus 4. So all I did was plug in -1 to both and added them together. 5 plus -4. Same thing as 5 minus 4. Okay, on this one, that's what I was doing a second ago. G of -1 is -4. So we need to figure out what f of -4 is. What's -4 squared? 16 times 2 is 32, plus 3, 35. Okay, C is f times g. So what kind of problem is that going to be? We're not plugging anything in, it's just saying f times g of x, just the general x.
Is that like foil?
Yeah, that's a FOIL problem. That times that. So, what's first?
10x squared. Or 10x.
10x cubed. Outside, 1 times 2x squared, 2x squared. Let me scroll over here. Inside, 15x. And last, whoops, 3 times 1. Okay, none of those are like terms, so that's the end of the problem. Okay, D, we're going to take all the x function, or the f function, and put it into the g function. So in other words, I'm going to take all this stuff right here, the f function, and put it into the g function where the x used to be. So it's going to be 5 times 2x squared plus 3 plus 1. And I guess we'll simplify that a little. Use distributive property right here. 10x squared. 5 times 3 is 15 plus 1 is 16. Guys, let's keep your answer yourself. Okay, number 3. Okay. So this one says state the inverse and whether it's 1 to 1. Guess we didn't talk about 1 to 1, did we? That's okay. Okay, how do I do an inverse?
Just flip the values.
Flip the x and y. So yeah, basically what inverse means is all the x and y values switch. So hopefully this will be an easy one for everybody. No, well, actually, it says, is it a one-to-one function? So a one-to-one function, you know how to make it a function, it has to, all the x values have to be different? So this is a function, but the original was not. The original relation, I should say, is not a function because the 2's are repeats here. To be a one-to-one function, the x's can't repeat and the y's can't. So basically both of these have to be functions. So it is not a one-to-one function.
And that's where it's gonna go to test, 1-to-1.
Yeah. Basically, if both the function and its inverse, both these two are functions, then it is a one-to-one function. Okay, you guys done with that? Thing. Number 4. I don't know if we did that. I'm not 100% sure we did this one. You guys can tell me.
Yeah.
Don't make me know what I'm doing. This is function composition right here, just putting functions together, but that's not what, I'm not quite done yet. Show whether, I don't think we did do it now I think about it. That's okay, we'll do it today. What did we miss it? It's not really hard. So if these two functions are inverses, then when you do f of g of x, maybe I'll just change it to this problem. It should equal x. If they are inverses, this should come out as x. Okay, so it's kind of a repeat of 2D. It should work both ways actually. So f of g of x should equal x, or g of f of x should equal x, either way. If this comes out, simplifies to just an x right here, then they are inverses. So maybe I'll just change it to this on the test since we should know how to do that. So in other words, like pick this guy up right here, put him in the other function, and simplify. So what happens, what do I get when I multiply by 3 here?
X plus 3. No, wait, X plus 3.
No, you're right. X plus 3 minus 1, which is x plus 2. So these would, these are not inverse functions. So I guess if I would have had like minus 3 right there, like right there, they would have been. So let me change it so you can see. If that was a minus 3, that would be a minus 3, and this would just be x. And in that case, it would be, yes, they are inverses. It's like everything cancels out except for an x. So just as an example, but this one wasn't. So I think for this problem, I'm just gonna have you do a composition function, f of g of x, and just show me what it equals, just like number 2D. Composition just means like combining, putting things together. Alright, are we done with 4? Number 5. Say f of x equals 2x squared minus 1. State a rule for f inverse. Graph both. Cadence. Do the problem.
I forgot how to do
How do we find an inverse function?
Switch it.
Oh.
Switch x and y, and then solve for y.
You dumb? Yeah. Oh. Retard.
Sorry.
This is the only graph. So I'm not gonna. There's some. I still don't think I'm gonna hand out graph paper. We'll just freehand it. Okay, so this is the original function. This is like a y. I switch the x and the y value here. So how do I solve this for y? Add the 1 over. Divide by 2. I'm gonna split that up. So this is 1/2 x plus 1/2. Divide them both by 2. Then what's the last thing that I do? Square root. And when you do the square root thing, remember
Plus or minus.
that it's plus or minus. So the inverse function is plus or minus the square root of 1/2 x plus 1/2. That could be kind of tricky to graph. Basically you can just plug in x values and see what you get. I'm going to show you a way to kind of make it easier though. Alright, I'm going to erase this.
It's taking us 5 minutes, a problem. It's taking us 5 minutes, a problem.
Okay. Okay, let's start by graphing this guy right here. You guys know where the vertex is going to be for this one? If you weren't sure where the vertex is going to be, you can just make up some numbers and plug them in and see what you get. But does anybody know where the vertex is going to be? Huh? What is the Do you guys know what that 2 does to the graph?
It makes it go up 2 times.
Makes it go up twice as fast, so it's gonna be skinnier. What's minus 1 to the graph? Down 1. So the vertex is just down 1. Going up twice as fast. So in other words, if I plug in 0, I should get negative 1, which I would. And then just to help me graph, I'm just gonna make up some other points, like if x is 1, well, what do I get here? 1 squared times 2 minus 1 is 1. So 1, 1. So if 1, 1 is a point, then I know the twin point, negative 1, 1, is also going to work. If I plug in 2, 2 squared times 2 minus 1 is 7. So that'll help me with another point. 1, 2, 3, 4, 5, 6, 7. I think it's about right there. So negative 2, 7 must also be a point, because it's symmetrical. That's enough for the f of x graph. Okay. Figuring out what to plug in here could be confusing. You could plug in anything you wanted to, really. But there's kind of a way we can cheat. Does anybody know how we can kind of cheat for this inverse graph?
Graph it first.
Okay, remember on number 3, you guys remember number 3? If you just switch all the x and y values, those would be the inverse function. So you don't have to plug stuff in. You could. You should get all this. So if 0, negative 1 is a point, then negative 1, 0 is a point. Okay, that's going to be the vertex, quote unquote, of the inverse graph. So what happens is the graph kind of flips like this, like it's here, and then it kind of flips like that. So it should look like a parabola going sideways. If 1, 1 is a point, you flip those two, 1, 1 is a point, which means the inverse, or the reflected point would be down. Oops, actually, you're right. More like right there. You guys see where I'm getting that from? If 1, 1 is a point, then you flip those, 1, 1 is a point on the inverse. If 2, 7 is a point, then guess what? 7, 2. 1, 2, 3, 4, 5, 6, 7, 2. Which means there's a mirror point right there. Is the inverse a function? Is the original a function?
Yes.
Yes. Is the inverse a function?
No.
No. Basically, it fails the vertical line test. That was the test. Got it?
Yes, sir.
Let's move on to logs. Fun with logs. That takes so long. Whatever. Number 1. Oh gosh, dang it. Okay. All right. Well.
Upside down 7.
Huh?
In front of that equation.
The 1. Or no, it's not a 1. It's a 6. What it was. Okay. Do you guys remember how we converted from log form to exponential form? ACB. Here's the thing though. They put the y kind of on the opposite side of how we normally write it. So it's, remember normally it's ACB?
It's A.
So now it's ACB. Does that make sense? Is this going to screw us up?
Yes.
No, it's not. Never.
Never. So normally, the way we wrote it is like this. Right? Log base 3 of x equals something. That's usually how it was written. So, but they wrote the equals y on the other side. Just, I don't know why they did that, just to make it harder. Okay, that's 6a, we'll call it 6b. Same thing on the b. It says evaluate. Okay, so what would 6a be? So it's a, c, b. So it's 3 to the y equals x. So if you can just remember that the 3 and the x, like these two numbers right here, are your a and b, and then c is over there, so a, c, b, 3 to the y equals x. And then we've got the same problem over here. Usually we've had something more like 4 to the x equals y. So it's a, c, b. So log base 4 of y equals x. All right, 7. How could I solve this?
Plug it in.
Plug in your calculator, or if you don't have a nice fancy calculator, what do you plug in?
Log of 512 over log of 2.
Log of 512 divided by log of 2. That would work also. So same thing on this one. Log of 8 divided by log of 1/2, or 0.5, I guess would work. Whatever that comes out to. 2, 4, 8, 16, 32, 64, 128, 256, 512. Should be 9. 2 to the third is 8. Therefore, 1/2 to the negative third is 8. Anyway. Or you could say 1/2 to the third is 1/8. So 1/2 to the negative third. So anyway, the first one you should get 9, the second one you should get -3. You can check that, make sure you got it right. There's a couple more calculator problems. I might just skip that for time's sake. I think we're doing fine on time, but I might just skip it. There's a couple more calculator problems where you just plug it in your calculator. It says round to the thousandth place. What's the thousandth place?
Third.
No.
Third.
Three digits. Tenths, hundredths, thousandths.
What do we do on the worksheet?
10,000.
We did 10,000s on the worksheet.
Sorry. Just need to make it mine.
Did you ever have to make up your mind?
No.
Pick up on one and leave the other behind. Yucky.
My bad.
What?
10 is like great. That's awesome.
I'd rather have 10 than 40 though.
Huh?
I'd rather have 10 than 40.
Yeah? This close?
But if you miss,
Wait, what did you say? You said you thought we had 10
No,
minutes?
I'd rather.
you miss 4 out of 10. You miss 6.
Yeah, you just get 10 out of 10. And you get 100.
Not all of us are
alright.
that smart.
And it takes less time.
Yeah, but if you have
What the heck?
20 questions, you have a lot more room to mess up.
You're
I know that.
Okay.
That's why I need 20 questions.
On number 8, we got a basic log function. So how do I set up to solve for b?
Turn it exponential.
Turn it into an exponential function.
Aren't you smart?
So ACB, so it's b squared equals 9. So if b squared equals 9, then what could b be? What would be b?
3.
Plus or minus 3. Square root of 9 plus or minus 3. I don't know if I've ever seen a log with a base that's negative.
Oh my gosh.
I don't know why it wouldn't work though. Okay, number 9. So notice how we have logs on both sides on this one, and they're all base 3s.
We can add.
Do you guys remember solving problems like this? Log of, say, 5x equals 100 or something, or equals log of 100. If you have log of this equals log of that, then these two things have to be equal. Okay, so it's just 5x equals 100. So on this one, if we can simplify, if we can put these logs together, then we can use that trick. Okay, how can I put these logs together? What can I do with this 3 right here? Okay, you can move up as an exponent right there. Yeah, what do you do when you're adding the same logs together? You multiply. You do 3x times x cubed. Yes, 3x to the 4th. And then kind of similar on the right side. These two are added together. So you can do 4 times 12. What if there was a minus right here? What would we do? Divide. Okay, I think the one on the test is actually a minus right there. So anyway, so there is one divide thing. And then once you get log of this equals log of that, this and that, 3x to the 4th, would have to equal 48. Now we're back to basic algebra. How do I solve for x? Divide by 3. If x to the 4th is 16, how do I solve that? What's the opposite of 4th root, or 4th power? 4th root. So what's the 4th root of 16? You can plug that in your calculator, but 4th root of 16 is 2. I'm not 100% sure the one on the test works out that nicely, but it does. The directions do say round to the thousandths place, so maybe you'll get a decimal on that one. I made it work out nicely, but you might get a decimal. Okay, number 10. Yeah, this one will definitely need a decimal. Okay, so I got a basic exponential equation. How do I solve it? Turn it into a log. So on number 8, we turn the basic log into an exponential equation. On number 10, we turn the basic exponential equation into a log. So it's ACB. Log base 7 of 5 equals 4x. This we can do on the calculator. But I'm trying to solve for x, so what do I need to do with that 4? Divide by 4. So remember that you can do the log stuff. One option you could do is log 5 divided by log of 7. If your calculator does not have a change of base option, and then whatever that is divided by 4. That will give you the answer. Let's go ahead and somebody tell me the answer on this one so I'll round it off.
0.268.
0.268?
0.2068.
Okay, so going with their directions, it would be 0.207. About. Getting close, getting close. We got 3 questions left. Okay, so next question, number 11. How much will $5,000 be worth in 10 years if invested at 4% and compounded quarterly? So we're running out of time. Okay, so this would use what? Compound interest from number 1B. So it's the A, the original amount is $5,000. The interest is 4%, which I should change to what? 0.04. If I'm compounding quarterly
Over 1.
over 4 to the 4 times 10. So just plugging the numbers in. K from 1B stood for how many times you're getting paid per year. So if it's quarterly, you're getting paid 4 times per year. T stood for the time, 10 years. You plug that in, that'll give you the answer. Okay, let's say there's 35,000 people in Bartlesville. I think it's almost that, or a little bit bigger than that maybe. In Beeville. And let's say it's increasing 1% each year. How many people in 5 years? So what formula are we using?
Normal interest.
Yeah, the basic interest, or what I call it. Simple exponential growth. Just the basic formula. So same thing, 35,000 is your initial amount. You're gonna multiply by 1 plus, what's 1% change into? 0.01, and just take that to the 5th. That would do it. All right. Sorry, I'm going fast, but I'm running out of time. 13, or whatever problem we're on. The last problem is graph this. Okay, how would I graph that?
Then make the table.
Oh, yeah. Table.
Right there. So just use those 5 points, plug them in. They put a graph for you. It does say state the domain and range. So there's also that.